Step into the realm of a spine-chilling story that surpasses any horrors you've ever heard. This tale is not the work of just one person, but an entire community. Brace yourself for the terrifying narrative of cannibalism and the haunting laughter that accompanies it. Get ready to be gripped by the unsettling depths of this eerie reality, where the very essence of humanity unravels and fear knows no bounds. Welcome back to Weird Facts, and today, the topic is Kuru, the Laughing Death. Before we continue, please smash that subscribe button, press like, and drop us a comment. Your engagement really helped to grow a small channel like us. The symptoms crept upon the victims slowly but relentlessly. It all started with mild headaches, joint pain, and slight trembling in their hands and feet. However, these symptoms progressively worsened. The afflicted individuals experienced increasing clumsiness and incoordinated movements. Eventually, they lost their ability to walk altogether, suffering from severe muscle spasms and uncontrollable shaking. But the most unsettling part was yet to come: sudden outbursts of laughter or tears, even without any apparent reason. Confusion, delirium, and paralysis soon followed, rendering them unable to move, speak, eat, or communicate through eye contact. Finally, after a year of enduring these horrifying symptoms, death inevitably claimed them. This was the sinister and incurable kuru, a neurodegenerative disease that haunted the four people of Papua New Guinea for nearly a century. The kuru epidemic remained shrouded in mystery for over half a century. It was only in the 1960s that groundbreaking research shed light on its true cause. Initially, Australian soldiers who invaded New Guinea during World War I reported a strange and incurable disease among the indigenous people, particularly the Fore and neighboring communities like Awa, Yate, and Usurfa. The Fore called it kuru, which means to shake or to tremble, perfectly describing the progressive loss of muscle control and the fatal outcome. The disease had grown into a full-blown epidemic by the 1950s, claiming the lives of around 204 individuals every year. At first, Western observers dismissed kuru as a psychosomatic phenomenon, attributing it to the Fore's beliefs in witchcraft and spirit possession. The Fore themselves believed that rival sorcerers inflicted kuru upon them by creating kuru bundles, consisting of the victim's body parts and various materials, which were then shaken daily to induce the disease. However, American virologist Daniel Gajdusek and physician Vincent Zegas strongly disagreed with the psychosomatic explanation. They observed clear signs of neurological damage in advanced cases of kuru, such as drooping or crossed eyes. In 1957, Gajdusek and Zegas initiated a scientific study of kuru, seeking to uncover its true nature. Their research, published in the Medical Journal of Australia, suggested that kuru might have a genetic origin, passing through family lines. To confirm this hypothesis, medical researcher Michael Alpers and anthropologist Shirley Lindenbaum embarked on an extensive study in the eastern highlands of Papua New Guinea in 1961, supported by a grant from the Rockefeller Foundation. Over the course of 2 years, Alpers and Lindenbaum discovered that kuru did not strictly adhere to biological relatedness, but primarily spread among individuals connected through complex social associations and bonds. This finding disproved the genetic transmission theory. Furthermore, they ruled out transmission through air, insects, or contaminated water. The unexpected truth they uncovered stunned the scientific community. Kuru was transmitted through cannibalism. The Fore people practiced a form of mortuary cannibalism, consuming the bodies of deceased family members as a way to honor them and return their life force to the community. Bodies were buried temporarily, allowing maggots to infest them before being exhumed, dismembered, cooked, and shared among the community. Interestingly, they avoided the bodies of those who died from certain diseases but regularly consumed those who succumbed to kuru. Alpers and Lindenbaum noticed that women were mainly responsible for preparing the bodies, and women and children consumed the brain, which was the organ most affected by kuru. Men, on the other hand, showed a preference for consuming the bodies of other men. These observations explain the higher prevalence of kuru among women and children, with only around 3% of 4 men being affected. While the evidence pointed towards cannibalism as the root cause of kuru, scientists still didn't know what actually caused the disease. In 1968, Alpers collected brain tissue samples from a deceased 11-year-old 4 girl who had succumbed to kuru. He delivered these samples to Daniel Gajdusek, who injected them into the brains of chimpanzees. Within 2 years, the chimpanzees began exhibiting the characteristic symptoms of kuru, and autopsies revealed their brains to be riddled with millions of microscopic holes, resembling a sponge. This groundbreaking experiment confirmed that kuru spread through infected tissue and directly attacked the brain. However, the exact pathogen responsible for kuru remained a perplexing mystery. The breakthrough in understanding kuru came in the late 1970s when researchers, including Gajdusek, noticed similarities between kuru and 2 other diseases: scrapie, affecting sheep and goats, and Creutzfeldt-Jakob disease, CJD, a rare neurodegenerative disorder in humans. These diseases were untreatable and fatal, just like kuru. In a series of experiments, scientists demonstrated that scrapie could be transmitted through sterilized infected brain tissue, suggesting that the causative agent was a rogue misshapen protein called a prion. These proteins were resistant to destruction by heat, radiation, and chemicals. The discovery of prions as the culprits behind kuru provided a groundbreaking understanding of the disease. Prions are abnormal proteins that cause normal proteins in the brain to misfold and clump together, damaging brain tissue and leading to neurological degeneration. This revelation led to Daniel Gajdusek being awarded the Nobel Prize in Physiology and Medicine in 1976. The kuru epidemic and its connection to cannibalism serve as a chilling reminder of the complex nature of diseases and the unexpected ways in which they can be transmitted. The story of kuru stands as a testament to the resilience and dedication of scientists who relentlessly pursued the truth behind this enigmatic disease, unraveling its mysteries and expanding our understanding of neurodegenerative disorders. Unlike bacteria, protists, fungi, or viruses, depending on one's stance in a scientific debate, prions, short for proteinaceous infectious particles, are not considered alive. Instead, they are abnormal proteins, different from the healthy ones found in humans and animals. These misshapen prions cannot carry out their original biological functions. When a person or animal is exposed to prions, they attach to normal proteins of the same type, causing them to transform into the misfolded form. This sets off a deadly chain reaction that gradually destroys the host tissue. While prion diseases are typically acquired from infected hosts, they can also arise spontaneously when normal proteins mutate into the malignant prion form, triggering the same transformational process. It is believed that kuru, which emerged in Papua New Guinea, originated when an individual developed the disease spontaneously and then spread it through mortuary cannibalism within the 4 population. The term, transmissible spongiform encephalopathy, describes the collective name given to diseases like kuru, Creutzfeldt-Jakob disease, CJD, and scrapie. This name refers to the sponge-like holes that prions create in the brain tissue. One well-known example of a prion disease is bovine spongiform encephalopathy, BSE, commonly known as mad cow disease. BSE is also transmitted through a form of cannibalism, although of a different kind. In the 1980s and 1990s, a major outbreak of BSE in the UK was linked to the use of meat and bone meal, MBM, in animal feed. This meal, derived from parts of animals not suitable for human consumption, including brain and nerve tissue, led to the widespread transmission of BSE. The outbreak devastated the UK livestock industry, resulting in bans on British beef worldwide, numerous animal deaths, and even human cases of variant Creutzfeldt-Jakob disease, VCJD, from consuming contaminated beef. The UK subsequently banned the use of MBM in ruminant animal feed, although it remains present in some pet food products. Prions were first isolated in the laboratory in 1982 by Stanley Prusiner, an American researcher at the University of California, who was awarded the Nobel Prize in Physiology or Medicine in 1997. This groundbreaking discovery opened up an entirely new field of research into communicable diseases and prompted geneticists to reevaluate certain assumptions regarding the transmission of structural information between genes and proteins. Scientists now suspect that a prion-like mechanism may also play a role in diseases such as Alzheimer's, offering new avenues for treatment in the future. Despite the progress in understanding prion diseases, mysteries still surrounded kuru, the first identified human prion disease. Even before cannibalism was suspected as its cause, missionaries and colonial officers discouraged the practice among the Fore people. By the 1960s, the Fore had largely abandoned mortuary cannibalism. However, the epidemic persisted for several more decades, with deaths averaging 7 per year between 1987 and 1995. It was later discovered that kuru has an exceptionally long incubation period, lasting anywhere from 3 to 50 years between infection and symptom onset. This extended period allowed cases to appear long after the cessation of cannibalistic practices. Notably, no cases have been reported since 2010, and the last recorded death from kuru occurred in 2009. Furthermore, it appears that the Fore population may have developed immunity to kuru over time. A study conducted in 1996 found a high prevalence of a gene mutation called G127 among the Fore, which prevents the infection of the brain by malignant prions such as kuru. Genetic analysis revealed that this mutation emerged as recently as 10 generations ago. This development indicates that the Fore community has undergone genetic evolution in response to the kuru epidemic, providing protection against future outbreaks.